Assalamualaikum warahmatullahi wabarakatuh. Hi everyone. Um, Let me share with you the chapter video for chapter 3 and 4. Okay. So this video is for chapter 4, part 1 and part 2. I make another video which is more proper sound, because I discovered that the previous video in the YouTube is not good. So let me compile all chapter 4, part 1 and part 2 in one video. So this about digital colors, right? In image processing, we have color processing. So so this is an example of color in a fabric. So we can choose, we can filter whatever color that we want by using color processing. So if you want yellow, then we can use color filtering to get only yellow objects in this fabric. This is a fabric. Okay. Okay, so you can go to here in MATLAB. There is a color demonstration video, so you can watch the video and try to understand how color processing work. So in this slide, we are going to cover what are digital colors, what are color spaces, why do we have different color spaces. When we look at to an object, it is actually the combination of object itself, light source, and sensor. Sensor means that the camera, and the camera. If no light source, you cannot see the object. So the colors that humans and cameras perceive are determined by the nature of the light reflected from an object. Okay, so that's the concept of colors. So colors is actually fall under the wavelength. So this is the wavelength of color. We call it visible spectrum. This is the common color spaces of image: red, green, and blue. We call it primary colors. RGB were chosen due to the structure of the human eye. So RGB are used in cameras. So this is the same slide as before. This is a wavelength of colors. We have additive and subtractive. Additive color and subtractive color. So this is RGB color space. if you still remember, on chapter 2, we learn image formation. We have RGB, right? Color space, RGB. So R represent for red, G is green, blue is color. So combination of these three, red, green, and blue, then you have color image. So this is the cube of RGB, 02255, 02555 for red, 02255 for green. Then which with this combination, we will have a color combination of the red, green, blue. For example, if we have 128 for red, 251 for green, 60 for blue, then we have green color. This is another color space, CMY and CMYK color models. So this CMY and CMYK we can get it from RGB by using this formula. Okay, so we back to the RGB. This is the red component. RGB is combination of red, green, and blue. So when we combine these three components, we will get this color image, original image RGB. So we can perform a color conversion. We convert color to grayscale. Color is in three dimensional, which is R, G, and B. Grayscale is only two dimensional, two value. You have a row and also column. Okay, this is grayscale. So this is one method to convert color to grayscale. Divide by 3. There are a few methods based on formula. So you can use any kind of conversion. Okay, so this is another conversion equation. So to convert the image in color to grayscale, we can use this weightage of each red, green, and blue. Conversion of color image to grayscale. So R plus G plus B. So this is the weight method. Okay. Next is a color thresholding. Color thresholding can be used for filter. I mean, if you want to detect certain color space, we can use color thresholding by using this color thresholding lah. TH, red, R. If we set a certain range of red, green, and blue, then we can get the color that we want. Then we can filter out the color that we don't want by using this coding. If red greater and less, if G greater and less, B greater and less, we get the object pixel, else non-object pixel. Okay, this is the coding for color thresholding. If the intensity change, we need larger TH. Non-object pixel will be detected. Solution, separate color and intensity. Okay, so this is the we can use this formula to overcome a problem of intensity in the discussed in the previous slide. In order, instead of we use direct red, green, and blue component, we can change to this. We call it chromaticity. So do thresholding in chromaticity, so you will get a better color thresholding output. We can You can try this example. Given an image in RGB format, detect the red object using color threshold. So this is another color spaces, SSL. So you can read it. You can read yourself. Other color also one of the color space. This is how to convert from RGB to. Okay, we can perform segmentation based on color. For example, we want to perform segmentation based on HSI. So this is the original image. Then when we analyze the original image in HSI color space, we get hue, intensity, and saturation S and saturation. So we can use these three color spaces to do a segmentation based on color. Okay, binary saturation match threshold 10% of maximum value. This is histogram. Then finally we'll get this red color here by using HS. Okay, so this is another space LED. Okay, all right. This is more practical exercise, pineapple color detection. We want to detect maturity of pineapple. So based on these three images, we can know yellowish of pineapple. You see this apple image 3 here is more yellow compared to the another two. So we can use color processing to detect maturity of pineapple, right? Okay, so same goes to color phase detection. So we can detect color, we can detect phase based on color, right? Because it is very obvious the color of face compared to the shirt, compared to the hair, compared to the background. First, convert RGB to gray because it is easy to analyze image in gray. Okay, then after conversion, we get three region, one black, two white, but these two white also can be considered as a two region, different region, one, two, and so we can based on the region we can select a face